In this seminar, we are going to explore Octave package data frame. Package data frame will allow us to deal with data sets and the process data processing more effectively. So these are the topics I'm going to go through. What is data frame and the installation for the package data frame, accessing data stored in the CSV files, and manipulating data in data frames, and some other topics that we're going to open to for discussion toward the end of the seminar. So first, data frame. So what is a data frame? A data frame can be thought as an object of the following. You can think of a data frame as a table of variables in columns and values in rows. And each column is a vector of data of certain type. And there might be a missing data, either empty or NAs. And as well, the data are associated with some common operations. For example, find the mean, max, and the standard deviation, and some other more complicated, sophisticated operations on data. So let's take a look at this example. This is car data from the data sets in R. So in this table, we see a number of columns. The first column are the car models, and the second column, that's the mileage per gallon, and then the number of the cylinders, and displacement, and the horsepower, and so on and so forth. So this is a typical table of data that we see from day to day. Now, quite often, we might want to extract the data, certain columns from this data set. For example, we want to extract the car models, mileage per gallon, cylinders, and the horsepower. And as well, sometimes we just want to get a grid of cells from the data. So some typical operations, for example, extract a subset of data according to a certain criteria. For example, find all the records of cars with the 6 cylinders, or fuel economy less than or equal to 6 liters per 100 kilometers, for example, or find the mean, max of a column, and find the sum, mean, and standard deviation of a column by group in another column. So data frame provides a convenient and effective way for data access and manipulations. Access columns by names, so the relative position in a column in the data set is irrelevant. This is the most useful feature. So for example, you've written a code for some data set, do data processing. And later on, the data set, the column, the relative columns in the data set has changed. Now, without the data frame, these features, you might need to modify your code accordingly. But with the package data frame, and you can simply refer to the name of the column or name of the variable. So the relative position of the variable or a column in a data set becomes irrelevant. And the second, the operations are normally vectorized. That means the calculation can be efficient. And the data frame data frames are well supported in R, Python for a long time. And now it is supported in Matlab, it's called data table or data set, and in Octave as well. And in Octave, it is called Dataframe. And through the package Dataframe, it is claimed that it is implementation or similar, an implementation similar to the Dataframe in R. Now, just want to point it out that this Dataframe for Octave, it is not. it does most of the Dataframe as the R does. But if you primarily work on Matlab or Octave and wants to do a common data frame, it uses some of the common data frame features, and then this package data frame for Octave might be good enough. And the current version is a 1.2, and the documentation is minimum. So one would have to have a good grasp of an Octave programming language, especially the features for vector operations and the cell arrays, and etc. So next, I'm going to switch to the online demo. So throughout this seminar, I'm going to just do the online demo, just walk you through the most of the features I want to talk about today. Okay, so we've got this package in. Want to see where the package is installed. So just install my Octave. Okay. All right. So now the package is installed. Let's load data frame. So the data frame is loaded. The next, I'm gonna load a file from load the data from disk file. Okay, so I got this file loaded. So list it again. So now what you can see is a table containing different columns. Now I want to load from another file. If we take a look at the original CSV file. Oops. Now take a look at the original CSV file. The CSV file, the values are separated by commas. The first line contains the headers or the names for each column. Okay, and the rest of the lines just the values. The first line here is the header or the names for the variables. Now let's take a look at the second file. The second files, the data are stored in a different format. It doesn't have the header. It doesn't have a header, and the values are separated by a bar. So now, how do we load this file? Again, we load data frame. Now, we load the data from this file. This file is called 2. Now we need to tell the function data frame that the separator or delimiter. The delimiter is the vertical bar instead of a comma by default. Now we have this file loaded in. Now, as you can see, because this file doesn't have the header, it automatically labels each column by x1, x2, and etc. Okay. Well, this is how you load a CSV file with the different delimiters. Okay. So you pass in an option, sept, and then the option, the name of the option, separator, and the actual delimiter. So now let's load the file again from the previous one with the headers. Oops, data frame. Now, the next command we want to see is we use the command class, and then let's see what this object D is. The D, we just read the data from the CSV file and store it in the variable D. And let's take a look at what the D is. And it says that D is a class of data frame. Okay. Now, how do we extract the name of each column? Now, D is an object, and there are a number of functions defined for this object or class. So one of the functions is conames. If we do just conames, it will return an array of the names of each column. Okay, and then we can use the command size to find the size of this data frame. It gives you this is a two-dimensional object. It's a table. It's the number of rows and number of columns. And also, we can use the function columns. That will just return the number of columns. And as you can see, and rows will just not return the number of rows. Okay. Now, next, we're going to extract the block of data. So let's say I want to take the column from 1 to 7. I'll take the subset of this data frame. So here's the outcome. I take the column from 1 to 7. And then I can assign this to a new variable. You put a column. Column means all, refers to all the rows, all the rows, and then the 1 to 7. So we get this a new variable D1. Now we want to get, say, from row 1 to 10, and then column 1 to 7. This is nothing new; it's just Matlab thing or Octave thing. We take a subset of the data. Now we can also use the names of variables or columns. We want to take row from 1 to 10, and we want to selectively take X and MPV, MPG, cylinder, and horsepower, the columns. So this also this returns a subset of the data. And then again, we can define the columns just by giving an array of column indices. So I'm taking column 1, 2, and 4, and as well we can take any order. Take all the rows from column 1, 3, and 2. That just gives me what we want, what I want. Now, it doesn't have the data frame doesn't have the command head or tail like R implemented, but we can easily get that. Want to get the first head by default. The head command in R just returns the first 10 columns, and the tail will return the last 10 columns. Let's do this 1 to 10, and for the rest of the columns. So that's the first 10 rows, or you can do the last row. This and is building a variable, building a variable that refers to the very last element of an array. And likewise, we can do tail and just the last 10 elements, last 10 rows. Oops. Perhaps we don't have that many. No. I want to go. Okay, so this returns the last 10 rows of the data frame, or you can do the other way around. I believe it's -10 to 10. The same thing. But again, this the indexing I'm using here. It's nothing new. It's just the regular Matlab or Octave operations. So next, I want to extract a subset of data according to certain criteria. Okay, so let's say I want to take the MPG, the mileage per gallon, for greater than 20. So this is what I'll do. So this return in that particular column mileage per gallon, and with sorry, this is wrong. With the mileage per gallon greater than 20. So as you can see, all the values returned are greater than 20. Or I want to return the data set, the entire data set, but with the cylinders greater than 6. So this will return a subset of the data with cylinders greater than 6. Now, in the original data set, I only have three types of the cylinders: 4, 8, 4, 6, and 8. And the greater than 6, that will be all 8. If I change that to greater than or equal, then that will include 6 as well. Okay. Now, the next, I want I want to extract the subset of data with a cylinder greater than 4 and horsepower greater than 100. This is what I want to do. So I'll use this command. I put the condition cylinder greater than or equal to 6 and the horsepower greater than 100, and for all the columns. Okay. So that will return all the data set with all columns, but with the cylinder greater than or equal to 6, and the horsepower greater than 100. Okay. Now, the next, let's take a look at this. Say I want to take the second column. Now it returns me the second column, and let's take a look at what it is. What type of this return object is. Oops. It says this is a data frame. It returns a data frame. And then if I do D1 MPG, this is the second column. Okay, the same. This is the second column. Now this returns me values. So if I do class D1 MPG, so that returns the type is double. So there's a difference. If you do the data frame, and if you refer to the second column with the integer, that will return a data frame. But let's take a look at this. Is the original data set, and the second column is MPG. If you use the name, then it would return an array of values. This is the fundamental difference. Now, if you do D1 array second column, it will return an array. Okay. Okay. Next, we're going to do something. We'll do a more exercise on operations on a column. Now we can find the mean of mileage per gallon, for instance. The mean function can be applied to an entire column, or we can find the mean of horsepower for those greater than the horsepower greater than 100. Okay, this is what we do. So we take the column HP horsepower, and with the condition greater than 100, and this will return me the mean that for the subset of the data. And also we can count the number of cars with cylinder greater than or equal to 6. This is number of cars. Okay. All right. So next, I'm going to take a look at another data set. Let me just load the data from another data set. I want to load the data from Gapminder. This is a different data set. Okay, so okay. Yeah, so the name's wrong. Reminder data. Okay, so data is being loaded in, and let's take a look at what's in it. So it's a table, and it contains the country, year, population, continent, life life expectation, and the GDP per capita. Let's take a little bit more. Let's say 30 rows. Okay, so I want to get the continent. So let's say let's make it easier. Give another name, and the continent equals G continent. So that will return me just the column of continent. Now, so what's happening here? But if I do G continent, and do so that will return the full names. So what's happening here? It turns out that this is a array. It's a chart array. The continent here, the continent here, the column contains the character arrays. So in order to get the strings are stored in a character arrays. In order to get the full display, we want to use a command, cell string, and do continent. And that will return the full names. So the next, we want to get all the European countries. We want to get the data from all the European countries. How do we do that? So we want to do this. So we want to take the data subset from the data gap, and by this criteria, and we want to search the continent that match name Europe, and we want it for all the columns. We want to get all the data. We want to get all columns, but with the continent, with the column continent, match the string Europe. This is what we want to do. Okay. So this will return me a subset of the data that contains only European countries. So next, I want to find, let's say, I want to find the countries with a population greater than 100 million in year 2007. Okay. Now, how do I do that? So I'll write a command here. Now, I already here I already defined a new variable g, so just for shorthand, for gap. So I want to take a subset from the original data with this condition: the population greater than 100 million, and the year of the data is 2007. So this returns me the data, all the countries with a population greater than 100 million for year 2007. And the next, I want to calculate, for instance, I want to calculate the population of Europe. So how do I do that? So first, I'll extract the column population. No, sorry, I get the extract the countries in Europe, and then I will apply sum on this data and to the column population, and this will return the total population of Europe. Okay. So next, let's see how to add a column and how to add a row. Now remember back to the original, the first data set, D1. And the D1, we want to add a column. And before we're adding a column, let's do this. We want to get the number for columns. The number of columns in this case is 7, and then the number of rows is 32, and then we make an array. Do this D1. Now D1, we want to add a column. So in other words, we want to append a column to the original data set. So we add a column, append, with scalar, the number of rows. Okay, so now we added a new column to original data frame D1. This is now column number 8. We can also add a row. Let's add a row. Let's define a row first. Use a cell array, and then we append this row to data frame D1. So this is we add a new row to the data set D1. We define a row in cell arrays, and then we simply just append it to the end of the data frame. Okay. Now, next, how do we remove a row or column? So D1, let's say I want to remove D1. Let's take a look at D1 again. Let's say I want to remove the second column, MPG. So how do I do that? So simply do D. So for all the rows and the second column, put empty. So it's gone. Or you can do D1. I want to get rid of the HP. column horsepower, and then you do empty array. Now it's gone. And similarly, you can remove a row. Okay. To the next, to replace a column. Let's say I want to replace the column. Which column? DSP displacement with something else. So I can do D1, number 1, 2, 3, number 4, number 3 with something else. Let's just make it up. That should be 1, 1, 1. Okay. So you can simply just refer to use the column index and replace with an array. Now, how do we build a data frame from the vectors? Next. Now we want to build a new data frame. We want to create a new data frame. So we want to create a new data frame with the city, province, and the population, with some initial values, with two records. Okay, so I define the names, the first names, and then separated by the semicolon, and then the first set of values, and then followed by the second set of values. So now I have a new data frame population. It is new data frame. Now, how do I add a new record to this data frame? I can simply do this. So I want to add the population of Montreal. So this new record is being added to the end of the data frame. Okay. All right. And I'll jump to set the name of a column. How do I set the names of a column? Let's take a look at the first data set again, D1. And the D1, now the first column is X underscore score. How do I rename it? And now we can do this, D1, call names. And the call names, and we know that's the first column, so I just use the index 1, and let's say set model. So now the name has been changed to car model. Okay. Next, we want to find the position of this column WT. And how do we do this? And let's define the variable names, and this will return an array of names. Okay. And now I want to find the weight. I want to find the index, the column index, the weight. And how do I do that? So I need to use the Matlab or Octave function find. And the find And the condition is find the name find in names that matches not HP but WT weight. So this returns the column index 5. That's 1, 2, 3, 4, 5. Okay. And then once you know the index, then you can rename. So this will be useful when you are dealing with a data set or data frame with 100 columns or hundreds of columns. This is how you refer how do you quickly find that a column with a given name. The operations I'm doing here is given a column name, how to replace it. So the first, find the column index of that column with that name, and then rename. So that we can know we can do this. So D1 call names, because we want to change this column name WT to something else. I want to give it weight. So now it's being changed, renamed to the weight. Next, there is a useful function called a summary. This is specific to Dataframe. Summary is a function. Let's say what it does. D is the original data set. D1 is a subset of a original data set. Let's say what it does. Oops, it's hard to see. Let's apply to D1. So it gives you a statistical summary of what's happening. So let's take a look at a D1 first. D1, we have these columns. And then the summary of the D1 returns this. For each column, for each column, and we see this is a mean, max. This is a statistical values that might be applicable to the specific data types. For instance, the cylinder and the max, min, first quartile, median, and mean, and the same thing for displacement and the weight and so on. Okay, and for the first column, the first column, the data type is a factor. So none of these mean or max will apply, but it gives you the counts, the number of occurrences. Okay, so this function summary is very useful. That gives you a summary of the data frame. Okay. Lastly, we can quickly take a look at the aggregation operations. So what we want to do here is we want to find the mean. We want to find the mean of mileage per gallon. Let's take a look at the data set again. D1. We want to find oh, we don't have the mileage per gallon anymore because I took them out. Let's take a look at the original data. Okay, yeah, this is the original one, original copy. So we want to find the mean of mileage per gallon grouped by cylinders. Okay, in other words, we want to find the mean. First we want to sort by the cylinders from going from 4, 6, and 8, and then we want to find the mean or max or other value within a group for 4, 6, and 8. And how do we do that? Here is let me do this first, and we want to use the function unique, and we apply to cylinder. That will give that gives me 3 values. Yeah, so we only have three types of cylinders: 4, 6, and 8. And now for each one of them, for each one of this array, we want to find the mileage per gallon. Okay, so this is we want to find the mileage per gallon such that the cylinder number for cylinders is equal to one of the arrays returned by the unique. And then we want to apply this to apply mean to this function, and then we need to use the Matlab or Octave function, array function. Okay, so oops. I want to do this. We want to use the original data frame, not D1, not a copy, because we already done something to the copy. Okay, so this is what we do. So first, we find the groups. We identify the groups or list, and then, sorry, this is not max. We want to apply mean. And then we want to apply the mean function to this column, mileage per gallon. That satisfies the condition that the cylinder number for cylinders is equal to the element, one of the element in this list. We're going to go through this list with this function and then apply the array function. This is a little bit twisted, but this is the way to go. So as you can see, you can find the max, or you can find the mean. And also, I think you can find a standard deviation as well. Okay. Yeah, I think I've gone through all the exercises that I want to demo, and I'll now open to discussion.